In this video, we're going to talk about how you can include resources, such as the example we're going to use is text files, in our C# projects. In a video later on in this series, I'll show you how to embed other kinds of resources like graphical files in a C# project. I'm also going to talk about a style of programming called Fluent style and when you should use it and when you should not. So let's get right into it. I want to spend a little bit of time looking again at the Solution Explorer window, which is this window over here, that tells you what are the various parts of a Visual Studio solution. So you see we have a solution, and then we have a project, and then there's a bunch of stuff in here. Right? So there are properties here. We have a bunch of properties of the project itself. I'm going to talk about what goes in this file in a later video, so I'm just going to skip it right now. We already talked a little bit about the references. The references tell Visual Studio this program that we're writing makes use of a bunch of code and a bunch of different libraries that were written by other people. Most of them were written by Microsoft. But you can see we've got references to system and system.core and system.data. And these are all added for you automatically when you create a new project. There's a configuration file in here. I don't think we've looked at this before. It's just a little XML file, and it says nothing interesting except that this program was designed for .NET version 4.5. So there's a bunch of stuff in here. There's a bunch of stuff in the project. And so I just want to make sure that we're clear on what all the nomenclature here is. So there's a solution. Right? A solution consists of one or more projects. So far, we've only seen solutions that consist of a single project. A little later on in this course, we'll look at solutions that contain 2 or 3 or more projects. The console projects that we've been building produce an assembly. An assembly is a redistributable unit of code. Right? It's got its own version number. And it's usually either a .exe or a .dll. The exe files are standalone executable programs. The DLLs are libraries that are usable by other programs. We'll discuss assemblies in more detail at the end of this course. But right now, I want to talk about some of the items that you can have in a project that are not code. So let's take a look at that. All right, so if I go to this project here, not to the solution, but if I go to the project and I right-click here, I get this context menu. I can go to Add, and I'm going to say I want to add a new item. And the new item that I'm going to add is I'm just going to add a text file. All right, so now I have a little notepad-like text file right here, and I can just add some stuff to it. You know, whatever. And I can save that like I can save any other file. And so I've just created a little file. I've added it to my project. And that's all well and good. Now, you might think, suppose I have some configuration information, right? Or I have a list of words for a word game or something like that. I have some large body of information. I would like it to be in just a plain text file. Maybe I want to read that file in my program and understand what's in there, but I don't want it to be in C# source code. How am I going to do that? How am I going to keep that stuff in my program? Well, one thing you could do is you could do what I just did. You could add a text file to your project, and then when you ship the code to customers, you should make sure that you always ship that text file with your code and make sure that the code knows how to read the file and all of that stuff. The problem with that would work. Lots of people do that. The problem with it, though, is it is a little bit error prone in that somebody might delete that file. Somebody might edit that file. Somebody might put information that you don't expect into it. So something that we can do in Visual Studio is create items in projects that are logically embedded within the assembly itself, within the code that you're going to ship to customers. So I want to talk about how to do that. So I'm going to rename this file. I'm going to rename this word list. All right, so I've renamed this file. So it's now called wordlist.txt. Suppose I wanted this thing to be embedded in the assembly itself, that it will ship directly with the code itself. I can right-click on this thing, bring up the properties dialog, and then in this little properties down here, you see the build action right now is set to content, meaning just this is a file. It could be a specification. It could be part of the program itself. The Visual Studio doesn't know and it doesn't care. It just thinks that you've added the text file for some reason to this project. Now, if I select from this dropdown embedded resource, then when I rebuild this project, Visual Studio will include that as part of the assembly itself. And we can see how that works. I'm going to save this, close that, open that back up again. And let's step into this code here and take a look at how this works. So the first thing I'm going to do is I'm going to get the currently executing assembly. Right? So I have an object of type assembly. And when I take a look at this thing, you can see there's all kinds of information in here about this assembly. The version of the runtime it's using, where the code was found, all the stuff that the .NET runtime needs in order to execute the code that's in this assembly can be found here. There's a method on assembly called getManifestResourceNames that returns an array of strings. And it turns out that there is a resource in this thing called video08 wordlist.txt. Well, I already knew that, so I'm going to create a stream. Remember, a stream is an abstraction over the idea of there's a bunch of bytes somewhere, and I want to read those bytes one at a time. So I'm going to create a stream. I'm going to get the manifest resource stream of that name out of the assembly. And I'm going to do this using a using block so that when I am done reading the stream will automatically be closed. Now, last time I used a stream reader, I just gave a file name to the stream reader. What happened there was the stream reader created a file stream and started reading the file stream. When the stream reader was closed, it automatically closed the file stream. Since I've created my own stream here, and I'm going to hand it to a stream reader and say, stream reader, please interpret this thing as text, I'm going to put a using block around both of these things so that they are then closed one after the other. All right, so I've created my stream. I've created a reader on top of that stream. I'm going to call read to end on that thing, which just grabs all of the text out of it. Now, normally, if we were using a stream reader, we would read it, say, a line at a time in case it were really big. And we could do that here. But just in the interests of time, I'm just going to read all of the text in at once. You can see there's the text, and then write it out. A quick note here. I think I explained this in the previous series of videos, but just as a reminder, in Microsoft Windows, if you have a new line character embedded in a string, the way Visual Studio shows that is \r\n. And that means you can imagine that this was for an old-fashioned teletype machine. That would mean return the carriage to the beginning of the line and then feed a new line down, which is sort of logically what happens when you insert a new line into a string, right? The line number goes up by 1, and the place where you are going to be printing out the next bit of text goes back to the left margin. So anyway, our using blocks are done, and we have read all of the text out of this stream, right? Something I want to make a quick note about. Anytime that you have this pattern of you have 2 or more using blocks like this, it is very common to see it formatted like this. And Visual Studio will allow this. It won't automatically reformat it if the code is like this, just because it's a little bit easier to read. You often end up in these situations where you create a resource that needs to be disposed, and then from that thing you create another resource that needs to be disposed, and then from that thing you create another resource that needs to be disposed. And the using blocks can get deeply nested, and that makes it hard to read. So Visual Studio allows you to format it this way. I want to make a useful abstraction out of this thing. It seems like it would be very useful to have a method that just gives me the word list. So what am I going to do? Well, as we've discussed before, I always like to have a one-sentence specification for any method that I write. So I'm going to say get word list as a method that obtains the word list resource in the form of a list of strings. So here we have the code that gets the executing assembly, gets the stream, gets the reader. Now, what I had up here was I had just a string containing the text, including all of the new lines. What I want is an array or a list or some kind of collection of strings. So in this version of the code, I'm going to split the text. How am I going to split it? I'm going to split it on whatever the new line character is. And fortunately, the .NET base classes have an environment.newline constant that I can use here so that I don't have to type out the \n's and \r's and all of that. I'm going to remove the empty entries, as we discussed in a previous video how that works. That's going to give me an array. There is an extension method on arrays called toList that turns it into a list of strings, and I'm going to return it. Right? So let's just step into this code real quick here and see how that works. All right, so I'm going to step in. I get the executing assembly. I get the stream associated with the word list. I make a stream reader on top of that stream. I read all the text in, so that's given me this text. I split the text into an array. That gives me this array. So I have alpha, bravo, Charlie. I turn that array into a list. Now I have this list, alpha, bravo, Charlie, and then I return it from this method. OK, so quick question. Is it OK to just return like this? Because remember, we still have a stream and a reader that are open, that are consuming a resource. Now, in this case, it's not a resource that some other piece of code in the file system is likely to try to get. But still, it's really, really good practice to always close any resource that you open. So is this good? And the answer is yes, this is good. The using block will dispose the resource as soon as control leaves the using block. And return definitely causes control to leave the using block because it causes control to go back to the caller. Remember that a using block is essentially a syntactic sugar for a try finally. If you return out of a try, then you are going to execute the finally before the return returns back to the caller. Right? So finallys, if control leaves a try or a using, if control leaves a try, then the finally always runs. If control leaves a using, then the disposal code always runs. Now, something to note about the way that I wrote this code was that it's very, very statement-oriented. Right? I've said, here's a statement. I'm going to introduce a new local variable, and I'm going to read this thing to the end. Right? And then I'm going to take the thing that I just produced, and I'm going to split it. And I'm going to put the result of that into a local variable. And then I'm going to take the result that was produced there and do something else to it, and put that into a local variable. And then I'm going to return this thing. Now, you note that in each case, the receiver of the call, so here the receiver is text, is the value that was just computed in the previous line. So this local variable is actually unnecessary. We could, I'm just going to stop this program for a minute here and comment that out. And I'm going to rewrite this code like this. So I'm going to say we have the reader. We're going to read it to the end. We're going to split that. Then we're going to turn that thing into a list. And then we're going to return it. Right? So in each case, this here is the receiver of this call toList. Right? This here is the receiver of the call to split. This is the receiver of the call of read to end. So this code is exactly the same as the previous code in its action. It just has a lot fewer statements and a lot fewer local variables. This style of programming is often called fluent programming because you sort of think of control flowing very naturally, very easily, and also because programs written in this style are often written in a way that uses English words in a very sort of natural way. You see a lot of code that has methods like select from and up to. And so, you might say, from 10 select up to 20, order by, and so on. You can construct interesting workflows using this sort of fluent style. The question I have for you is, which do you find easier to read? And which do you find easier to debug? It's often kind of a judgment call. Some people really strongly prefer the fluent style. Some people really strongly prefer the more sort of statement-oriented style. And I'm kind of in the middle on this. I prefer debugging code that's written in this sort of statement-oriented style because, as you saw before, I stepped and I examined the result, and stepped and examined the result, and stepped and examined the result. And if I'm trying to figure out exactly how a piece of code works, that's a really good way to do it. On the other hand, look at all of the extra text that is in here, all of the types and declarations and all of that stuff that are totally missing here, where this just feels very natural and very easy to read. What are we doing? We've got a reader, we're going to read it, we're going to split it, we're going to turn it into a list. Totally obvious what this stuff does. So I find the Fluent style very easy to read, but I find the statement style very easy to debug. Sometimes what I'll do is I will write a piece of code in the statement style, I will debug it, I'll get it the way I want it, and then I'll just tweak it so that it's in more of a Fluent style so that it's easier to read later on. It's entirely up to you. Try it both ways, do what you think is best. Summing up, embedding resources, great way to add information to a project that is not code. You can obtain a stream and a stream reader for the stuff that's in the resources, in the embedded resources, the same way that you would obtain a reader to a file on disk. Streams are a lovely abstraction over a sequence of bytes, no matter where those bytes are coming from. And the Fluent style that I just talked about is it's easy to read for some people, but it's harder to debug than the statement style. So consider using it, but use it cautiously.